Hello, this is Scott. Welcome back to my YouTube channel where I talk about a variety of different data science and analytics topics and cover some software, both commercial and open source. Today we're talking about R and time series. So continuing on with time series models, last time R32 we talked about creating non-seasonal ARIMA models, and we did that within R and covered some related topics there. So, but there's one thing I did not do last time that I meant to do. So I'm using this library FPP2 by Hyman. We looked at this time series of U.S. consumption, actually deltas or changes in U.S. consumption rates. And then we fit this model using Hyman, and we talked about the output from the model itself, the different phis and thetas from the model, the fact that we have a non-zero mean from the model, and that mean is 0.7463. So I did not, what I meant to do last time that I did not is actually use the forecast function to look at the forecast from the model so that we can see here, this is, it's almost an average. It certainly is drifting down, up slightly and then down with some pretty wide bands here, but this is the forecast for this time series itself. So I wanted to make a couple of comments, and what I wanted to say is that these are some things that you can expect from ARIMA. So we're using this auto ARIMA function, and anytime that you use something that's automatic, you ought to be a little bit wary, or I shouldn't say wary. You should be diligent and make sure that the model is fitting what you think it should do. So again, we have a 202, and if we have a 202 with a non-zero mean, it's this fourth case right here, the mean not equal to 0 and the differencing equal to 0, then the forecast will go to the mean of the data. And when we looked at R, that is kind of what we saw. So that's one of the things that we could check. But we also should check the autocorrelation function and partial autocorrelation function. So let me actually look at the autocorrelation function now. And what I have here, this is the FPP package, a little different than the native ACF in that this is actually lag 1, not 0. So all three, the first three lags are positive and significant. The fourth is almost significant. And then we could look at the partial autocorrelation function, right? Because this says that the first three are interesting. If we look at the partial autocorrelation, we do get the 3 as well. That being that if it were just the autocorrelation function itself, it could be that the relationship here is that 1 and 2 are related, driving 3, and that 3 is not significant on its own. However, when we look at the partial autocorrelation function, we can see that they are. So what this says is essentially that a simpler model may be representative of the time series. And that simpler model may be just an AR0, or just an AR3, AR3. In other words, a 0 differencing and 0 moving average. So what I can do here, let's look at this AIC. This AIC down here at the bottom is 342. What if I apply this AR3 model? Whoops. If I apply that AR3 model and look at the output for it, actually the AIC is 340. So it's lower, which means the model is a better fit. Not a huge difference, but certainly if you consider Occam's razor, this, you know, the simpler model is always optimal to a more complex model. The other thing that we could do is that when we use this auto ARIMA up here, it is actually doing not as an exhaustive of a search. It's basically is doing a stepwise procedure. So if I want to use a little more CPU time, but actually build out a larger search, I can set this stepwise to false and approximation to false. And then I can run that. And if I run that, I get actually this 300. So just a couple of different comments on how you can use this auto ARIMA, and then also specifically with, you know, what you ought to be looking for. Here are the basic relationships, and then certainly look at your autocorrelation function and your partial autocorrelation function. Hopefully that was meaningful, and I look forward to seeing you next time as we continue on down to ARIMA and actual seasonal ARIMA.